Welcome to SimplyGIS, GIS for everyone.
Hello everyone, welcome to SimplyGIS YouTube channel. In this video, I will demonstrate how to create and map watershed using SRTM digital elevation model or DEM data. A watershed is a land area where water from all streams and rainfall cumulatively drains to a common outlet such as river mouth, bay or ocean. This area is also called as drainage basin or catchment. Ridges and hills separating two watersheds are known as drainage divide. Elevation and slope determine the flow direction of streams and rainfall water to accumulate in a common outlet point, which is called as pour point in GIS. The Shuttle Radar Topography Mission SRTM DEM is a commonly used and openly available digital elevation model. I have a separate video on how to download SRTM DEM data from USGS Earth Explorer. You can check that. To start with creating watershed, we first need to fill the DEM data. To do so, let's go to Spatial Analyst tool, and in Spatial Analyst tool there is a toolbox called hydrology. Under this there is a tool called fill. Click on it, and here you have to set the DEM you are working on as an input surface raster, and in output surface raster save the DEM to a desired location. We have to set the type of raster .tif and save it. Okay, so you can see the field DEM is ready. After that, we have to create a flow direction map. So in the same hydrology toolbox, you can see there is a tool called flow direction. Click on it, and here input raster will be the field DEM, and the output layer where you want to save, go to there. .tif. You have to set that raster format, save, and let all other options remain as they are. Click OK. So you can see the flow direction map is here. These 1 to 28 values indicate different direction of the flow. 1 is the east, 2 is the southeast, 4 is the south, 8 is southwest, 16 is the west, 32 northwest, 64 north, and 128 northeast. After creating the flow direction map, we will create the flow accumulation map. Let's click on the flow accumulation. Set the flow direction as the input raster, input flow direction as raster, and click where you want to save it. .tif, save. Let all other options remain as they are. Okay. So here is the flow accumulation map where you can see this white line represents the streamlines. So to have more clear understanding of the streamlines, let's go to the properties of the flow direction and click on the symbology, and under symbology go to classify, and classes should be 2, and in the break values option, let's select, we have to set the break values. I am setting is 10,000. Okay, apply. You can see more and more streamlines have appeared in this flow accumulation layer. After having flow accumulation, we have to create a pour point. As I told you, pore point are the mouth where water from all the watershed area accumulates. So go to catalog, and in catalog, in the desired folder where you are working, create a new layer. So right click, create a new layer, new shapefile, and in a new shapefile write POU, pore point. Feature type would be point, and you have to set the spatial reference. The spatial reference for this DEM is Geographic Coordinate System 1984. So to set the spatial reference, let's click on the edit and click the Geographic Coordinate System WGS 1984. OK. Now create OK. So you can see here is a pore point created. Click on the pore point, and I'm making it larger so that that can be visible. And when the layer is created, our point has not been created yet. For that reason, right click on the pore point, edit feature, start editing. When you start editing is on, go to the create features. So you can go to the create features by going to editor, editing window, create feature. And in create feature, there you can see the pore point is here. Click on it. In the construction tool below, click on the point. And you can see the cursor has changed to creating points. So I have to set the pore point. If I click pore point here, it will take all these areas. So I am clicking this streamline as mouth of this streamline as my pore point. Be careful to place this pore point in white areas, not in the black areas. So click on it. So you can see one pore point has been created. Go to editor, save edit, again editor, stop edit. So you can see our pore point is here. When your pore point is ready, go to toolbox, and in hydrology, you can see there is a tool called Watershed. Let's click on the Watershed. It is asking for the input flow raster, flow direction raster. So select the flow direction as the input flow direction raster. And now it is asking for the feature pore point data. So here from the drop down, select the pore point. So when you have created set the input layers, save it to the desired location. .tif. Save. Click OK. You can see it has been darkened. It means the layer has been created, Kathua watershed. I am changing the color so you can see it. Apply. OK. So you can see our watershed area has been delineated. So this is the watershed for this pore point. If I select different pore point, the watershed area would be different. And this watershed reflects that water from all these areas will accumulate in this pore point. They will drain to this other stream through this mouth. So this is the pore point, and I want to calculate the watershed area. So right click on the layer, go to open attribute table. So this is the attribute table you can see for the watershed area we just created. From this table option, click add field and name the field as area and make it float and click OK. So you can see there is another column here. Right click on this column, go to field calculator, click yes, and you can calculate the area by double click on the count multiplied by 900. Why 900? Because you know the SRTM DEM spatial resolution is 30 meter. So 30 multiplied by 30 is equal to 900. So 1 pixel of the SRTM data covers 900 square meter. I want to convert it to square kilometer. So divide it by 1, 1, 2, 3, 4, 5, 6. 6 zeros after 1. It will make it to the square kilometer. Click OK. So you can see 330.76 square kilometer area falls under this watershed. In this way, you can create watershed of your interest. You can use this watershed boundary for further use, like clipping the dam with the watershed boundary, extracting the river lines, extracting the stream lines, and creating stream order for this region. Thank you for watching it. If you face any problem or if you have any queries, you can write them in comment or write us to our email address. SimplyGIS is offering 6 months course on basic of remote sensing and GIS. You can visit our website simplygis.in and check details about the course. It is a 6-month course. The classes will be held online on Saturday and Sunday. The time is flexible. Here is the registration form. You can click and register yourself. This is the detailed course structure. For more videos on remote sensing and GIS and tutorials of QGIS and ArcMap, please subscribe our channel SimplyGIS and also click on the notification icon. There are playlists on QGIS and ArcMap. You can check them.